All right, let's start. I think the first thing I have is the quiz. So look at that first. Zoom in some on that. That much. All right. So just kind of so the first one was a basic stoichiometry problem, and you were at STP. So that shortened it a little bit because you could use your 22.4 liters per 1 mole. You did have to balance it, so hopefully you noticed that it wasn't balanced. It had to be balanced with the chlorine. So just a pretty typical reaction on that one. And same thing with the next one. I feel like we've done several of these. Or we just had two separate things and then we mix them up. So you had to figure out the pressure of each one separately and then add them up. Dalton's law of partial pressures. And that one was just using one of the gas laws. It wasn't one of the noble gases. Oh, that's the bottom one. I'm on the wrong one. I'm sorry. This one is using number 2. Same thing, number 2, but we did use the ideal gas law. So number 3, some people, that one was one that was kind of a little hard for people. So, and I think some people I had a couple people that might've been looking for temperature on that, but this was your V1 and this was your P1 for your nitrogen. And then this was your V1 and this was your P1 for your hydrogen. And then that you mixed them together or you allowed them to mix together. So that means your V2 for both of them would be when those two things were open, because now they would have that full volume. So that's where this 12.50 is coming from on both of them. So then you would have just figured out your P2, which would be your pressure of each one when they were allowed to mix, and then added together to get your total resulting pressure. Yeah. Some people, I mean, quite a few people were trying to use the ideal gas law on that one, but it was just a little bit different type of approach to it. And that is actually a question that I got off the AP tests a few years ago, and I've used it. All right, any questions on that one? So the next one I think might have been another stoichiometry problem. Oh, this one you had to know. And this came from that little section in our things you need to know, that sulfurous acid, what it decomposes into. If you didn't know that, then it might have been kind of hard here to get going. And then after that, it was just a stoichiometry problem. And once again, you were at STP. So you could use that 22.4 liters at the end. You want to have any questions on that particular one? All right, good. All right, and on the next one, we knew how much of our pentane we had. And we were interested in liters of carbon dioxide, so you could have done this as a little bit of a stoichiometry problem, but here I just said it gave us that we had 0.2 moles of pentane, and it's a 1:5 ratio. For every 1 mole of my pentane, I'm going to get 5 moles of my CO2. So that's where you would get your moles of carbon dioxide. And then at that point, you would have everything you needed to go into your ideal gas law to get your volume. And I just left my pressure in millimeters mercury and just used my different value on that one. Questions, anybody on that one? Oh, I forgot to set all that up and I forgot to record, but I am recording, I think. All right. Okay. So those are all of that. And we'll still have a test over that. So let's look next at the other one. And I'm just going to kind of move through these, and if y'all have questions, then just stop me on that one. So if something is a reducing agent, that means it was oxidized. I don't think it has loose electrons. I think it loses electrons. It doesn't have loose electrons. I don't know. They may be loose. Anyway, so that means it's going to give up because in oxidation reduction, if something's oxidized, something else has to be reduced. They always go hand in hand. And I think everybody overall did pretty good on this first page, if I can remember correctly. I'm sorry. Oh yeah, I sure can. Good. All right. Just a little equation. That work there is for number 6. We had done one using KHP in our notes. It only has one acidic hydrogen, which you really didn't have to write an equation out. The fact that it only has one acidic hydrogen and sodium hydroxide, it only has one hydroxide, would get you the fact that it's a 1-to-1 mole ratio. So that means you could figure out how many moles of KHP you have, and that would be your same number of moles of sodium hydroxide if it was the neutralization reaction. On the next one, in the reaction of carbon and oxygen, the carbon is, so both carbon and oxygen went from 0. Carbon became positive, so it was oxidized, which it means it was a reducing agent. Number 9, I think maybe only one person got it right. It asked you some questions. You don't know the concentration, and it's saying, can you tell which one would take more? And the fact that hydrochloric acid only has one acidic hydrogen as compared to the other one having 2, it's going to take more of your hydrochloric acid if they're at the same concentration. So that was the little bit of the trick on that one that you had to recognize. That if I wrote some kind of equation out, I only have one acidic hydrogen here, I have 2. So that means if they were the same molarity, I would need more of the HCl to get the moles that I needed. All right, most people got number 10 right. I feel like the next few went pretty good. Number 13 was +5. All that scribble, I think I had to go in and change the key, but I think most everybody got that one right pretty much too. Anybody have any questions on any of those? And then we did a couple of things that were just memorization. Which of the following compounds are soluble in water? Basically, you should have been able to get rid of a lot of them. I think I jumped them. Or which one is soluble in water? I'm sorry, that one should have been pretty easy because it's the potassium, the group 1. Insoluble, you would be able to get rid of very easily the top 3. And then the other one should have been on your solubility chart, which you had access to. And then a couple where you had to do a little bit of problems. So number 17 would be a limiting reactant problem because you have 2 givens. So you had to figure out which one was your limiting reactant, and it was a 1-to-1 ratio. So that's what I was doing here. I was figuring out how many moles of each one I had. And sodium chloride was that one. So once I figured out that it was a limiting reactant, then it's the one I need to use to start my problem. Because all of it's going to be used up. The silver nitrate would be in excess. And then the next one, just pretty typical conversion. Luckily, nobody chose E. That was a good thing.
Did anyone choose E during the whole test?
Did anybody choose? I don't think so.
No.
All right, then I have 21 scratched off because I took that off. That's a thermochem problem from my old test. So I don't know that anybody got 20 wrong, and I know that there was a lot of struggle, but really it told you, like, people were trying to figure out what else was going on with it, or maybe somebody got it right and I just may not remember. But it tells you that ethanol was oxidized to acetic acid. So that's all you needed. That's just extra information. You needed this goes to this. And it says that was oxidized. So this is your oxidation half reaction. And then you would have to go and do your balancing. So my carbons were okay. So then that's when I would have added my water. Because over here I had 2 oxygens. So now I needed 2 here. And then I would have needed to get my hydrogen. So that would have been my next step. And then my last one would be to put my electrons. So just like any kind of typical test on the AP and on my test too, sometimes you're just given extra information that you don't even need. Like on that gas laws, I think on number 1, I gave you like the density or something and you didn't even end up needing it. So. But anyway, if you struggled on that one, trying to figure out what to do with potassium permanganate, you were not alone on that. All right. So on these, I feel like they went pretty good. I gave you credit, but really, if you're asked to write the balanced oxidation half reactions, that's this part. It's before you multiply it to get a common number of electrons. I didn't take off because I just didn't feel like I had kind of reinforced that a whole bunch. But really, if they ask you on the AP test, do it like when you get that half balance before you're trying to even up their electrons. That's why I have these 2 in parentheses. And I know we're all trying to, get through and do hurry up, but you know, if you're asked that on the AP test, don't then go back and start, you know, canceling some things out to get to your final one, because, you know, they're probably gonna say, oh, well, I guess that means that they didn't want that in there. So when you have take your AP test, make sure you make everything very clean. Because that was another thing that I had some people, they would wanted this maybe to be their half reaction, and then later on they went back to that reaction, started scratching stuff out or working through it to get to their overall. And I didn't take points off for that, but just, you know, just remember, if when you're taking the actual AP test, you want to be as clean about stuff and as clear as you can. We'll be here before we know it. It's the first AP test. May. Beginning of May, then we have the whole month of May. What's the pass rate for it? I don't know. I would have to look it up. It's not one, not extremely high pass rate. But you don't have to make a 5. You can get 3, gets your credit.
Yeah.
So you don't have to make a 5 or a 4. Well, there you go. We've only ever had one girl making 5 on it. That was my daughter for you, but I was not her teacher. This is Parker was. Miss Parker was a good teacher, and Alyssa happened to be good at chemistry. Except for my mom. All right, we ready to move on? All right, so next little one, I mean, I feel like people did really good on that. For some reason, there's a couple of different ways to approach it, and it seems like it's a lot of work. The way that I approach it is I figured out this is how many moles needed to be neutralized of the sulfuric acid. So then I went and I figured out how mixing each of those, how many moles of the, what am I trying to mix with? Oh, I'm not trying to, what am I trying to do? Sorry, I got myself confused. I figured out how many moles of the sulfuric acid you needed, and then I went through each of those and see which one was equal. So that's how I ended up coming with E. That's not the only way to approach it. So you may have found a quicker way to approach it than that. Did anybody do it differently? No. All right, let's move on to our next one. So this was, what were we doing here? Net ionic. So a couple of things on here. This is a strong acid. That's why it ionizes. I felt like maybe this one was not on the solubility rules. Did anybody struggle with that? Or no, did anybody look for it, or do you remember? Yeah, and so I think I gave you, whether you ionized it because it was soluble or whether you didn't, I gave you credit both ways on that particular one. Because obviously I didn't realize that when I had just printed out those solubility rules. But it is, you know, but I mean, ClO4, that's not an ion you're gonna like just probably have memorized. But you should have known that this one would ionize for sure, because that's one of your strong acids. Anybody have any questions on that one? All right, the next one was just little MAVANA1. So I think that one went pretty good. And there was 1 hydroxide and 1 hydrogen. All right, then we started on the bonus. So I really can't remember at this point how people did on this. I think maybe just ran out of time, some people. But anyway, another thing on this, that's hydrochloric acid. So it's gonna ionize. I don't think on this one, but on some of the other ones, I had some people that if water was produced, they tried to break up the water. But if you have a gas or if you have water produced, those are gonna stay together. Anybody have any questions on that one? And the next one, Raul would like for me to tell y'all that did not really happen in lab. He was not playing around, and Andrew really didn't get mad at him. All right, we just had that one last one. I'll just throw that on Google Classroom because the other part are the FRQ and y'all have all of that. So if you were interested in that very last one, I'll scan that in. All righty, y'all have a nice weekend. Be careful in your travels. Have a nice last football game. Stay warm.